Respected dignitaries and my dear participants, good afternoon to all. It gives me immense pleasure to welcome you all to the last session of eSESTEC 2020. We'll start this session with a brief introduction about SESTEC. So let me call upon, invite me Dr. V.K. Manchanda, a person with the vast experience in the field of separation science and the person who is responsible for initiating this SESTEC series of symposium. Over to Dr. Manchanda, please.
Good afternoon, friends. It is a privilege for me to moderate this panel discussion. We have distinguished panel of experts with varying backgrounds, and we have Dr. Kaushik from Energy, Shri Shinai from Chemical Engineering, Dr. Saxena from Radiochemistry Isotope Group, Dr. Ghosh from Lead, and I hope Dr. R. Kumar is there with us from ITTA. So I thought I will just share some background of this aspect for all those who are not familiar, actually, relatively young people. The first aspect was held in 2004, and this series was approved by Interfuel Cycle Committee of BNS, which was that time chaired by Dr. S.K. Banerjee. And the first edition, we had it in this multi-purpose hall here, where Dr. Mashelkar, Director General CSIR, was the keynote speaker, and Dr. Anil Kapoorkar, Chairman AEC, was our chief guest. In fact, I just want to mention that Dr. Kapoorkar had been chief guest for SESTEC for many editions. Actually, initially, the theme discussed at SESTEC were related to BAE activities, particularly nuclear fuel cycle. It was realized that separation science and technology play a key role in the production of high purity materials, which are relevant not only in atomic military but in space program, defense, electronics, and pharmaceuticals. So after some deliberation, it was thought that it is good to interact with experts in diverse areas and exchange the challenges faced and solutions arrived at in those areas. It may be of mutual interest to different industries, including atomic energy. So in 2008, SESTEC, for the first time in Delhi University, when we had this program, we introduced the topic of biomolecules. The experience gained encouraged us, and now the SESTEC organizers, they have decided to widen the scope to include more areas, particularly treatment of industrial effluents, pharmaceuticals, speciation. We have presentations both in basic as well as applied science. In fact, I want to give an example. In the last session yesterday, which Shinai chaired, it was an excellent talk of one of our own students who now moved to Canada, how to manage the mixed liquid waste arising from the nuclear establishments, have a lot of carbon-14, strontium particularly. It was the applied program. Then there was another presentation which was on basic science from Oak Ridge National Lab by Dr. Bruce Meyer. And he was talking about how we can separate lanthanides from each other using dichloromide, which our Dr. Kaushik knows. We are using it more for actinide partitioning, but he was more specific on recovery of ruthenium, praseodymium, which is again a very important area, and it is going to catch the attention of the new technology people in the years to come. So SESTEC will be very grateful if the experts on the panel share their observations about SESTEC 2020 and their advice for the future editions of SESTEC in regard to the scope as well as format, so that it can serve the purpose of the community and separation science and technologies all over in an agriculture. With these words, I will like to stop and hand over the mic to Chair Shri Kushi.
Thank you, sir, for briefly describing the SESTEC. Now we'll start the panel discussion. It's my honor to introduce you to the various experts which are here with us for the panel discussion. We have with us Professor C.P. Kaushik, Associate Director, Nuclear Recycling Group. He has played pivotal role in development and demonstration of innovative technology for separation of radioactive components from waste for societal benefit. He is joined by the Shri Shinoy, who is Associate Director, Chemical Engineering Group, and his field of expertise is in the field of sizing, selection, and design of various hydrometallurgical plants involving state-of-art tools like process intensification and process and modeling and simulation. We are also joined by Dr. R. Kumar from IG CAR. He is head analytical and spectroscopy division, and his area of expertise involved radioanalytical chemistry and various development of various novel separation methods involving chromatography and neutron activation. We also have with us Shri Saxena. He is head radioanalytical chemistry division, and his field of expertise is on chemical characterization of nuclear material and trace analysis. We also have with us Dr. Asim Ghosh, who is expert in membrane science and technologies. Now I request all the members to take up the panel discussion. Thank you.
Good afternoon, Dr. Mantala sir, Senaji, and host. Indeed, it's a pleasure for me to be in the panel discussion and share our experiences with respect to SESTEC of this year, as well as the way it has been nicely narrated that we started the journey of SESTEC way back in 2004, and it has been very simply made very clear by Dr. Mansalaji that separation science really play an important role not only in nuclear fuel cycles, at the same time our day-to-day problems, let it be industrial effluent problems. All of us are aware that there is surrounding to most of the important or even small towns, you have huge water coming from different industries, and then looking at a very complicated formulation, and really it becomes a challenging situation for a chemist or for a technologist, for that matter, to make sure that we are able to separate the toxic components from them. Similarly, to talk about the role of separation science to start with in nuclear fuel cycle, I'm sure all of us will agree that not only the front end as well as the back end, both our two important fuel cycles of nuclear science and nuclear technology, separation science play an important role. See, when it was almost to a learning stage, that time itself, I used to see a very active persuasion from Dr. Mantala Saab with respect to our CHON based extractants. They are used because by the time it was well studied by Dr. Mantala Saab and his group that our CHON based system has a promising tomorrow with respect to its deployment, not only in day-to-day part, but at the back-end side, when you have a complicated solution of waste. If you look at the waste, almost it represents a periodic table itself. If you look at the waste, it will have some constituents from alkali metals, right, to alkali earth metals. You have transition metals, you have lanthanides and actinides. Altogether, you are almost having a representation of a complete periodic table. And from there, if you have to really remove the active components, And let me tell you, maybe just I will take a couple of minutes, the benefit what we derived from the work earlier done by Dr. Mandadasan and the group based on our CHON based separation science. We were going for a vitrification of waste. And if you look at the waste, inactive components of high level waste, almost is around more than 95%. And active components is only 5%. But we were vitrifying as it is. That means 95% of the inactive component for which vitrification need not be done. Maybe there are other ways by which inactive elements, they may be active, may not be radioactive, but they may chemically active. But there are other ways by which they need not come through a vitrification stage and later on worry about the size of our geological disposal systems. But that was done earlier as well. But still we were doing because we were not having hands-on experience or a good professional platform where there was a possibility to exchange information with respect to the efficacy of those extractants. Because extractants need not only to do good, but at the same time it should survive in the hostile environment with respect to HNO3, because you have 3-4 molar and all. And more than that, you have an intense radiation as well. So all put together, it becomes a very challenging formulation if you really want that the particular extractant will we need to have a effective solution for removal. And just to give an example, once you remove the inactive components, very small amount of waste becomes ready for vitrification. But we were not happy still. A dil mange more something like. Then again, separation chemists came into for rescue, and again they told, look, there is some extractant like cholesterol, which can be can remove cesium-137 by and large with the good selectivity. We started working on the laboratory stage in-house based on the separation size knowledge of our standard. We could synthesize cholesterol. Dr. Manchanda is not here, but the whole group of BRs that we and cholesterol was synthesized, and then we started working on it. And today, more than 3 to 4 lakhs curies of cesium-137 has been recovered from high-level waste, and then they have been converted into glass pencil, which is non-dispersible in nature, and that has put our country first in the world. But if we look back, we say with pride, we are first in the world. But look back from where? It is because of the dedicated efforts of a separation chemist. Because a research done and need to get converted to technology, there is a wide gap. So I used to meet that time as a training officer or as a junior student to Manchanda, and we used to learn from him. And sir, today really we feel proud that now the developed part, maybe after 10 years or 15 years, they have got converted into an established technology, which has not only substantially influenced the footprints of geological disposal system. See, geological disposal system is a worldwide problem. Nuclear energy benefit one can take, but who is ready to have a geological disposal system? Nobody will happen. In fact, not only in India, it has been a problem, global problem. So, this knowledge of separation science, which comes through this suspect type of right from 2004. In fact, incidentally, when Dr. Bashelkarji was our keynote speaker, the job given by Dr. Mandada to me that time, that I was given the opportunity to go to airport and receive him, and then go stay in our NPCL guest house and have a chit chat with him, so that he's feeling okay, only I and all. And it was really a privilege for me, because Bashelkar is first an icon, and then that time itself it was a golden opportunity for me to meet an icon of similar discipline. So it was an inspiration for me. But the way eSESTEC has graduated, and today we are reaping the benefits, because being technologist, and I'm incidentally not only I'm a chemist also. So I have seen how the research and development has been done a way back, maybe some 12 years before. But today, when we are reaping and we say, look, we are the first in the world, and but the no, this is the fruitful result of dedicated efforts for our research and development chemists through a separation science and the exchange of information during our such type of conferences really play an important role. This is one typical example which I am giving with respect to the waste. Coming back to even for water. See, water also, nowadays, a lot of problems are coming in of the contamination. Sometimes we say there is some uranium at some part of the city in India. There again, there has been a problem. Nowadays, in fact, internationally, it is well recognized that India is now first country in the world which authentically tells waste is a wealth. Because if you look at cesium-137 is removed, strontium-90 is removed because it is being used for melting of yttrium-90. And all of us are aware the use of yttrium-90 an important radiopharmaceutical for therapeutic applications. And it is being sent regularly, not only to RMC, the other two Tata Memorial Hospitals. And the last which we have done, again based on the separation science, ruthenium-106, again which decays to rhodium-106, and all of us are aware that has got around energy of 3.65 or 3.68 MeV as a beta emitter to palladium-106. That beta energy is being exploited for our eye cancer treatment. And there was only one company in the world, Messrs. Vivek Germany, they were trying to give from there. And now, just to give an example of the benefit which separation science can give to a common man, one plague was costing around, it costs around 12 lakh rupees when we import from Germany. And when we started making it after getting all the regulatory clearances, after achieving all the purities required, and then initially we gave around 10 plagues to all the leading hospitals of the country, including AIIMS Delhi, including Shankar Nethralaya and Center of Sight Hyderabad. And initially they were hesitant because they were telling that we are only giving only 1/10 of the cost. That means your level of purity is not that good. Because by virtue, now we have that in our schools when we are friends, whenever we get imported. This is the watch and this is imported watch. We take a pride in telling something important. But when we started telling, look, Baba, you use it and have your own experience. When they operated for 15 number of patients, and then AIIMS director gave an email to our chairman AC, these plagues are at par with international products and surprisingly get to 1/10 of the cost. So then our PMO office and all, they again gave a tweet with respect to, but we look at from where got, again the origin of this benefit starts from the separation science. And separation science is not a alone which can be done. It has to be a good platform for exchange of information, technical information exchange. And sir, beyond doubt, I tell, because luckily I have been a witness of the journey of suspect right from, I have been to Delhi also, where, because I know sir is also a product from Delhi, and that time sir's batchmate was the chairman of chemistry department that time. Somehow I am not able to recollect the name, but I had a good time in Delhi, and sir has given me some responsibility at time there also in Delhi. From Delhi onwards, and almost every suspect in one way or the other, I have been a contributor to this. And I have seen we have graduated from stage A to stage B. Now our organizers also have become very professionals. The way we select our different variations with respect to invited talks, like some talks will be dedicated for nuclear, some talks will be because separation science influences all. The way it has been beautifully put, not only even defense, electronic industries, or even if you want to make a nanometal, again there are security required or sufficiency required. So the way we are now very nicely identifying the experts working in that area, bringing for changing. So this helps our youngsters a lot. I think with this, I really say that we have graduated from almost from a nascent stage where the first step was done, and today we are right to a very mature stage. And of course, we have to look for which are the areas further there we can master again. Probably, I think we are also giving some lectures or some presentation for the youngsters also there. So some youngsters also are given opportunity to give their presentations or not.
No oral presentation this
Oh,
time.
okay.
Maybe next time we can.
Maybe because sometimes if maybe just my submission, if we can maybe we can decide depending on the logistics. But some youngsters also, if they can be given, so he because sometimes by serving some 20 or 25 years, we lose thinking out of box because it had a time suspended. Those out of box thinking, I believe, can come from a youngsters in a better manner compared to the people who have spent a very good long time in the department, any department for that. Maybe giving some opportunity, depending on the logistics, may help us to also their approach with respect to some sort of out of box thinking to attend some of the problems in the environment. I think with this, I really summarize that SESTEC has played an important role, not only to the having maturity in research and development, but at the same time to arriving to a mature technology which has put our country on the driver's seat, at least in the field of back-end of nuclear physics. Thank you. Now I request Shinai sir, who has also a vast experience in not only synthesis of a selective extractants, but many innovative technologies, a vast experience with him. Sir, now I request you kindly to have your views on this occasion.
Thank you, Dr. Kaushik, Dr. Manchanda, and all my colleagues in this auditorium, as well as online colleagues. So it's very nice to be part of this SESTEC. It's an important symposium on gathering of separation science people. So I also have been associating with this SESTEC for a long time. Being a chemical engineer myself, separation plays a very important role for chemical engineers. So to restrict the time, I will be speaking about application of computational studies, rather what we call, which comes under the umbrella of molecular modeling related studies in the separation science. So this problem is always there between this classical chemistry, whereas theoretical chemistry, or classical chemical engineer versus computational chemical engineer. So this has been there in the engineering field for a long time. So now it is well accepted in chemical engineering. This computational chemical engineering, that's CFD, computational fluid dynamics based designs, are much better or improved versions of the conventional engineering. So because of this insight into the physics of this equipment understanding, so there has been a lot of improvement in the equipment performance. So now I see a similar fight between this computational chemistry, especially related to the applied side, like in the application of separation science, versus experimental chemistry. So I think this will continue for some more time until we have robust computational mechanisms. Of course, now with this improvement in the computational field, like incorporation of artificial intelligence, things are really changing dramatically, I must say. So, application of this computational, what we call computational experiments. So they have been well proven for solvent extraction, as Professor Manchanda told. So yesterday we had a wonderful lecture on this application of selection and screening of ligands for rival separation. See, it is a very difficult separation with the categories of diaryls. But this hardly there is any physical or chemical change in difference in chemical properties. So even for such a separations, to screen a ligand see its efficacy, select a suitable diluent, suitable modifier, everything based on computational chemistry. So I think it was a wonderful and systematic study. So I strongly advise freshers who are joining this symposium in this year, kindly go to that paper if it's available full, or at least refer to their published paper, because I think it's a very systematic study for application of computational chemistry to solvent extraction problems. Of course, this approach is being adopted by many researchers nowadays, both in India as well as abroad, and it's finding it very efficient because you are totally eliminating synthesis of all those hazardous, maybe, or very difficult synthesis, so many experimentations, so many analyses. So all this are now efficiently being done through computational chemistry. And second application of computational chemistry is in chromatographic separations. So this is also being extensively used nowadays. So chromatography itself is being explored for, of course, in addition to lean separations, recovery of value materials from lean solutions, and nowadays even for isotope separation. So there are a lot of studies where screening of ligands has been done for isotope separations and even value separations using chromatographic separations. Even this simulation of adsorbents using zeolites and metal organic frameworks, even those have been simulated. So that clearly shows this computational chemistry is coming into the mainstream. And the next subject, which is heavily discussed nowadays, as Professor Manchand also told, is application of membranes. So I strongly advise all the separation people, membranes will be the materials in the time to come. Not only for separation of value materials, but even for recovery of value material from the waste stream, which quite a few examples has been given by Dr. Kaushik, and also recycle of water is going to be the burning issue in the days to come. So even in terms of membranes, as a separation scientist, suppose if you go on the material side, fantastic developments are being done in membranes, both in polymeric, whether it's hydrophobic, hydrophilic, depending on your customized membranes for your separation. There are membranes now, composite membranes, charged membranes. Even now people are applying ceramic membranes. So the field is fantastic and literally exploding like anything. So I think we must focus on these membranes as a mainstream in our separation science. I strongly feel in the days to come. Definitely there will be a lot of papers. Of course, this time on the modeling side, there was one paper on development of graphene oxide based membranes, so, which is now being used for waste separation. So this field is really exciting. And there are a lot of studies of computational science and chemistry in diffusion of solids, diffusion in solids. So one good application, and one, I think there was one paper on optimization of vitrification process, so which Dr. Kaushik mentioned. So when they have studied through fundamental quantum calculations, what should be the loading of this waste solutions in the matrix, effect of different radio elements on the loading. All those have been are being studied now. So this is also a fantastic study now. And I remember there was one paper last year where this study of mass transfer and the interface was presented by, I think, our BIC colleagues. like my colleague Dr. Mushraf. So this is a fantastic application of MD simulation to the interface studies. So where he clearly showed how these different species transfer across the interface before they come to the equilibrium. Let me tell you, these are it's maybe very difficult by experimental, but it gives a lot of insight as an chemical engineer for me to develop a equipment. Because the moment you have a transfer of species across the interface, how their property changes, especially with respect to viscosity and interfacial tension, definitely this experimentally it's very difficult. But if you can get those information through molecular modeling, I tell you, this will be a very valuable input to the chemical engineer. Because in fact, that's how we extended this modeling aspect from atomistic to continuum. So we don't see days are very far off when I get the input from computational chemistry and implement it in the CFD, there is macro scale modeling. So I would say this computational chemistry is a beautiful field and a challenging field, both for beginners as well as for experts. So we can get a lot of insight. And just a small sort of warning or to the new people who want to venture into this molecular computational chemistry science. Of course, it's very easy to get PhDs with the computational chemistry because it's very easy to generate papers. But please mind very famous jargon in computational science: garbage in is garbage out. You must be very careful what sort of data you are feeding into your program so that you don't get misled by your output results. So that's how the role of classical chemistry and your fundamental understanding will remain, whereas computation chemistry will help you in further understanding your or validating your experimental observations. So I would say with these things, I hand over to the chair.
Thank you very much, sir, for your very valuable suggestions and touching on the various challenging areas where our investors can pick up the problems. Now, I will request our Saxena sir, who heads our area in the analysis division, to give respect to this particular function based on the science.
So at the outset, I would like to express my sincere thanks to the organizing committee of this symposium for inviting me as one of the panel members. So as said by the other panelists, actually the Indian energy program is based on the three-stage closed fuel cycle for the efficient utilization of the limited uranium resource and sizable thorium reserves. So separation cycle technology plays a very important role in nuclear fuel cycle. Starting from the mining to the fabrication of the material, isolation and pre-concentration. Isolation and pre-concentration of analyte for chemical quality, control measurements, reprocessing of irradiated fuel, and management of nuclear waste. So separation employed in such process are getting improved or replaced with the view to obtain better separation purity of product, chemical economical viability, and cost of production. So basically, I have gone through all the deliberations of the symposium, and it is heartening note that many such studies have been reported in this symposium. So I will be discussing some of those interesting and important studies. So one of the paper is based for pyro-based processing experiment were carried out to demonstrate the direct conversion of uranium oxide to uranium metal. So generally, that direct conversion of uranium oxide to metal conversion involves various lengthy process, but one study has been reported in the symposium by electrochemical reduction route. And as we know that uranium, the conversion of uranium nitrate to ADU, it involves a large separation procedures which is obtained by the Purex process. So one of the studies has been reported where they have converted this ADU by that directly by microwave denitration process. Now uranium nitrate to directly uranium oxide, which reduces the waste problem also. And then as we know that this uranium, plutonium, zirconium based fuel, which is proposed as a fuel for the fast breeder reactor, the Purex process is basically proposed for its chemical separation. But during the separation by DVP, that plutonium 4 and zirconium 4, they have lower solubility of metal oxide, and they will try to maintain this presence of uranium lead to the formation of third phase. So some studies have been carried out, and which shows that this how it can be avoided. The third phase formation, how it can be avoided. So like this, as you said, as said by Dr. P. Kaushik, that one study has been done for the bulk scale separation of radiochemically pure ruthenium from acidic intermediate level waste. So this was also discussed, which has got a very important application in the healthcare. And we know this Neptunium-237, which is a very long-lived fission product. So it poses two problems. One is with respect to the immobilization of the waste. But however, if it can be removed. If it is removed and it can be isolated, then it finds its useful application for the production of plutonium-238, which is used as a power source. And of course, this neptunium separation, it is a challenging task because it has a tendency to coexist in the multiple oxygen state 3, 4, 5, and 6. So there are some studies have been reported in this conference, but I feel that the large scale, it should be, the large scale has been reported, but if at least it can be pilot scale, if the studies can be extended to pilot scale, that will be beneficial. So another important study with respect to the analytical measurements was reported in this symposium, where for the direct measurement of plutonium in the irradiated fuel of FBTR. Basically, the challenge is that it has got very high radiation dose. So, and the measurement problem is also there. So, very important, very interesting work has been reported from IGCA Coral facility, where they have used this absorbance measurement for both for plutonium-4 and plutonium-6. And most important, there is no interference from the large amount of uranium. As far as this analytical measurements are concerned, basically because I am from the analytical side, so what I feel that the researchers who are working in the field of this separation science, they should aim at synthesizing some of the task-specific ionic liquid, some of the nanoparticle, functionalized nanoparticle, so that it can be used for the cloud pipe extraction for the pre-concentration of the analyte, which are present, which has got very low specification in the nuclear material. So if such task-specific ionic liquids are that nanoparticles with the help of cloud pipe extraction, so people should work in this field. Like I will give you one example. This zirconium, the specification of chlorine is something like 0.5 ppm. So some work has been done in this field, but still more is required to do, especially for the analysis of these very trace elements in the nuclear material, especially because I am discussing about the nuclear fuel cycle and I am from the front end user. So I will advise all the researchers to work on this field. So in my opinion, good number of papers are presented with respect to the separation methods relevant to nuclear materials. Most of the studies were initiated for resolving the problem, and they are of applied nature, whatever that work has been reported in this symposium. However, we shall hope that in future, SESTEC conference will discuss about the emerging separation procedure in the field. As you know, there are some new advanced nuclear fuels are getting involved with advanced nuclear materials with respect to burn-level poison or controlled materials. So, separation science plays a very important role. So, with this word, I finally concluded the organizer of SESTEC 2020, especially Dr. P.K. Pujari, Director, RC and IG, and Chairman, Symposium Organizing Committee, Dr. S. Jayakumar, Convener of the Symposium, Yanasis Bhattacharya, Secretary of the Symposium, Dr. V.K. Manchanda, Chairman, Technical Committee, and other members of the Organizing Committee for organizing, successfully conducting the symposium in this pandemic situation. Thank you.
Thank you, Sanaji. Now, I take this opportunity to request Dr. Kumar from IGCAR to express his views.
Yes, sir. At the outset, good afternoon to all. I'll have a brief account on chromatography and pyrochemical separation. As always, chromatography is one of the attractive separation techniques, the field enjoyed by most of us in our career sometimes or other. As expected, there are a good number of impressive works reported in the symposium proceedings on chromatographic techniques, either exclusively by itself or in combination with other techniques. The chromatographic separation in combination with other techniques were found to be the display of creative ideas in some of the works. The charm of the work was enhanced when they happened to be the problems dealing with our important requirement for our department or the problems associated with environmental concern, not necessarily associated with nuclear technology, but in general. The important types of chromatographical techniques dealt in the report includes ion chromatography, adsorption column chromatography, extraction chromatography, and high performance liquid chromatography. It is heartening to note that many colleges could interact with the DA units to enjoy the highly valuable opportunities to work with the costly instruments as well as interacting with our experienced scientists. Obviously, the department has absolved its responsibility of extending the societal obligations as well as the upgrading human resources of our country with respect to scientific values. Example can be cited as the case of work reported on the separation and determination of anions in river and estuary water using solid phase cartridge and ion chromatography by Rani Anna Government College for Women. Similarly, colleges from Kerala, Maharashtra, etc. also have benefited students. Similarly, assaying the atmospheric pollutants using biomonitors, very interesting work, that is MOSES by ion chromatography, is the display of our concern to serve the society beyond nuclear technology. Graphene oxide is one of the techniques dealt under this section, which is expected to remove various elements such as arsenic and ruthenium, which are of environmental concern from aqueous medium, etc. I am not sure about the efforts focused on taking this venture into the industrial scale, as we often come across the use of graphene oxide elsewhere also. Ion chromatography in combination with pyrohydrolysis is one area where the contributions and the effective utilization of the techniques are evident from the proceedings. BRC leads the expertise, followed by other units including IGCAR. Using this technique, chlorine from neodymium praseodymium oxalate reported from BRC, carbon in magnesium metal reported from control lab NFC, and nitrogen in uranium samples from pyrochemical samples using Geldal method from IGCAR were reported in this symposium. Solvent encapsulated beads appear to me to be a potential strategy for recovery of elements as described in the work TEDCA impregnated polyether sulfonate beads for rare recovery from magnetic scrap reported from BRC. Some of the challenging problems where chromatographic techniques are applied may include the work reported in the proceedings on separation of hydrogen from helium using palladium based adsorption column reported from BRC, and separation of zinc isotopes using column chromatography, again reported from BRC. There are also work reported on the separations using supercritical fluid extraction technique. However, I feel the scientific community is yet to explore the full potential applications of supercritical fluid chromatography in line with the vast application of the liquid column chromatography. It gives us an opportunity to appreciate the application of the chromatography technique in medical field, which we all know an extensive technique used in the field when we come across the work reported on separation of metformin and 3 SGLT2 inhibitors in human plasma using LCMS or MS from Gujarat University. We also come across the work on direct dissolution, the challenging task, and uranium extraction using room temperature ionic liquid with the SCF, supercritical fluid extraction, reported from BRC. However, I feel there is a wide difference can be made by using RTL in combination with SFE, which are yet to be explored to the extent what it deserves. There is an effort reported on the purification of strontium from yttrium matrix using supercritical fluid extraction from IGCAR, which may find a potential application for the production of strontium 89 from yttrium matrix, which is on its way to its industrial production. There are works reported to the essential analytical requirements exclusively important for the pyrochemical reprocessing from IGCAR, such as optimization of electrode configuration for a high throughput electrode refiner in pyroprocessing, which would contribute to the fundamental understanding of electrochemical reprocessing, thus enhancing the efficiency of the process. There is an interesting work reported from IGCAR under this section on direct burn-up determination of fast reactor mixed oxide fuel by preferential evaporation method for removal of interfering elements, where neodymium is analyzed by mass spectrometry as the fission monitor and samarium as the interfering one. There were a few observations which may be trivial and would have missed the notice of scrutiny because of the lack of time, that some of the chromatography work also is reported in other sections, which I missed to accumulate here. In some cases, the applications of the work was not highlighted in their work at all properly, leaving us to wonder why such exercise was taken up. Though it is the editorial committee which would filter such error, it is also the important prime responsibility of the authors to take care of the same. This is something which I wanted to point out. The example to this effect was on a work reported on neodymium, uranium, and thorium separation under this section, and somehow the others happened to have overlooked to bring out the purpose effectively. My briefing to this panel might not have covered the topic very critically, which may be due to my limited understanding to appreciate all the fields equally, and would kindly excuse me for the same. At last, I would like to mention an important observation that we are yet to utilize the radioactive tracer technique for various studies involved in chromatography techniques, as well as the underutilization of the radiation online detectors during the chromatographic separation. As we know, the detector plays an important role to decide the minimum detection limit and hence the sample size required for the analysis. With these few observations, I would like to thank the organizers for giving me this great opportunity, and thank you all again. Thank you, sir.
Really honored, and I feel I may not deserve to be part of this panel, but still you have given me this opportunity to talk about the membrane and water treatment part discussed in this SESTEC 2020. So at first, I think I should thank Dr. Manchanda sir, because at the beginning, if we can see from 2004 SESTEC and 2020 SESTEC, new topic we have introduced into that, and it is completely his credit. He told that in India, now we had a lot of initiative from Government of India on Ganga cleaning and water treatment part. So in first technical committee meeting, he insisted if we can include at least few talks related to the this topic. Then we tried to contact many dignitaries, and we got actually two very eminent personality for this talk. One was from Dr. Vinod Tare of IIT Kanpur, and he was closely associated with Government of India's Jal Shakti Ministry. And his talk, I'm sure that everybody might have enriched their knowledge on how to integrate the holistic approach to to know how to approach this holistic approach to get Earth Ganga river conservation development. So a key concept he has discussed in driving Namami Gange, Swachh Bharat and Jal Jeevan Mission. The second one by Professor Sanyal from IJA Kolkata. He talked about understanding the sources and processes of nitrogen cycle in the Ganga river basin using dual isotope of nitrate. And the first time the Professor Sanyal's group using the dual isotope in nitrate, nitrogen 15 and oxygen 18, very nicely he has discussed that from the Ganga river water to decipher the nitrate sources and nitrogen cycling process in the Ganga river basin. And based on this work, BRNS has given one project also because it is very important work. Then regarding another one, another talk was from Dor Avijar from Tel Aviv University. He talked about ozone-based AOP treatment of hospital wastewater. In Israel today, we can surprise that whatever problem Israel or maybe Saudi, where water resources are very limited, they are facing. One day, whole world can face that. So, Professor Dor, what his group was doing, what he told is Israel at present uses 85% of its treated effluent for crop irrigation, which is actually 45% of the total water used in the agriculture sector. So what he found from his research, that normal ozone advanced oxidation process, if he used the hospital wastewater because it is plenty, he thought that only it is possible to use for crop irrigation, but that water, if we want to use for the potable purpose, an additional treatment method is required. So these are just few examples of water treatment, whatever discussed in our eSESTEC-2020. Now coming to the membrane processes for the separation field, I just start with where Dr. Shenoy sir told. I fully agree with him that membrane separation can be think as a one of the very potential future separation process in any separation process we can think of. It may not be as a separation process, but as a combination of other separation process to give it more economic or more feasible. For example, one very nice talk was delivered by Professor K.K. Sirkar of New Jersey Institute of Technology. His topic was a few recent developments in membrane and membrane separation. There he took three examples. One, the recent result of separation of binary organic solvent mixture by reverse osmosis using a new fluorinated polymer. Second one was whatever many groups in the world, including our own group, is also doing, the graphene oxide flake-based membrane. And the third part is, of course, it is membrane distillation. I just want to mention few words about the membrane distillation. In normal desalination, so far we can think of the desalination of seawater or maybe little bit more concentrated seawater, like normal seawater is say 35,000 ppm. So using this reverse osmosis, that well-known and well-established reverse osmosis process, we can go up to 40,000, 45,000 like that. But many applications you will find that TDS, total dissolved solid, is 2 lakhs or 3 lakhs ppm. There, is it possible to use membrane? So there are few talks, very innovatively they have approached that yes, it is possible to even treat such high saline water also. So there they introduce this new membrane method, it's membrane distillation. It's not new in that sense, because in US and other countries, already they have conceived this thing in a plant scale of say 100 meter cube or 200 meter cube per day. So in membrane distillation, what is the advantage? Your membrane should be completely hydrophobic membrane, and whatever feed water is there, it should be little bit hot, like 60 degree, 65 degree. So wherever waste heat is there, you just heat that feed, even if it is having very high salinity of 2 lakhs or 3 lakhs ppm, then just put it in membrane distillation system. When it will give some vapor, this salt and vapor will get separated, and vapor will give the distilled quality water, or maybe at least drinking quality water. And this is, I feel, in membrane separation is one of the very attractive and means one of the future membrane process. Almost everywhere people are thinking. And another advantage in that is whatever membrane we are thinking, fouling will be very less, because there the foulants, typically solutes and all these things, they are not getting touched in the membrane. Only it is the vapor which is getting permeated through the membrane. Similarly, Professor Anil Vikramasinghe, he was he is executive editor of Separation Science and Technology Journal. He has also similar approach discussed about development of integrated electrocoagulation, forward osmosis, and membrane distillation. Yes, of course. Along with the membrane distillation, forward osmosis is another method. Forward osmosis is basically, it's a just simple osmosis, but try to make it a little bit in forward direction by manipulating the semi-permeable membrane between two feed with that draw solution of high osmotic pressure. So here very interestingly, he has explained that how integrating all these three methods most economically, how one can make the drinking water or better quality water from the contaminated water type of thing. Similarly, another paper was there from University of Calabria, Italy, by Enrico Trioli. He discussed about membrane system for a sustainable growth. So here actually only reverse osmosis and membrane distillation, these two processes may not be enough for all type of membrane separation. So his approach, what is told is, if we see, first we have to analyze the feed properly, then we have to design the membrane process in such a way, because every membrane process cannot work for all the process. So there combination of membrane process, again one has to think. And at last I want to highlight this part, that I have attended many exclusive membrane conferences like North American Membrane Society Conference, ICOM, in International Conference on Membrane. But I feel in a eSESTEC, being a wide area of separation science and technology part, only one part is membrane separation. But it is so rich in all aspects, like membrane development, its application. It is not on par. I feel it is much better than many conferences where even only membrane part is being discussed. So I hope in our next issue, in our next eSESTEC, we will incorporate still more number of membrane application part where separation chemist will be more benefited. As Senai sir told, that membrane separation is coming in a big way in time to come, and I hope all will agree with me. Thank you so much.
Thank you, Dr. Ghosh. I think we are with this we are coming to the end of this panel discussion. So I personally thank the organizers, Kumar and its entire team for present here. I would say they have very seamlessly conducted this entire session without any problem. Thanks to all. Thanks.
It gives me once again an opportunity to thank all the experts who have shared their observations, not only with respect to the job done by the organizers, even to the participants. They had some good tips. I hope all of us will get benefited by the advice of this panelists. So thanks all the experts of the panelists. Thank you.
Thanks to all the panelists for taking out their valuable time and being with us. Now we'll take a short break of 10 minutes and we'll be back after 10 minutes for concluding remarks and vote of thanks. Thank you.